All right, today we're going to be looking at chapter 6.3 of the Poisson probability process, or the Poisson, I should say. 3 objectives: determine if a probability experiment follows a Poisson process. 2, compute the probability of a random Poisson random variable. And then 3, find the mean and standard deviation of a Poisson random variable. So the first one here, you can see with this number 1, determine if a probability experiment follows a Poisson process. So here's the first objective. They give you the distribution. They tell you it's named after Simeon Denis Poisson. So it looks like poison when it's pronounced Poisson. And then here's the description. This probability distribution can be used to compute probabilities of experiments in which the random variable x counts the number of occurrences or success for a particular event within a specified interval. Okay, usually a time or space. Okay, so that's the Poisson process. Here is the definition and some of the properties. So what we're looking for the probability of 2 or more success in a sufficiently small subinterval is going to be 0. The probability of success is the same for any 2 intervals of equal length. And then 3, the number of success in any interval is independent of the number of successes in any other interval, provided that the intervals are not overlapping. So these are the 3 properties that we're looking for. So the second objective, number 2 right here, we're going to compute the probabilities of a Poisson random variable. So here is the description. X is the number of success, and we're trying to see if X is 1, 2, 3, 4, some number, some little x. And then here is the parameters. So we have lambda times t. So lambda is the Greek symbol that represents the average number of occurrences in some interval. And then t is the time length, or the interval length. And then we have x factorial, and then e to the negative lambda t. So the main parameter that we need is the mean. And so we'll be identifying what the mean is, what the interval is. And you can see an example here, which I'll let you do that one. And I'll do some in my math lab. The third objective here, number 3, is we want to find the mean and standard deviation. So as you go through this reading, it says, since the expected value of a random variable is the mean of the random variable, it's reasonable that the mean mu of x is equal to lambda t for an interval t. So then we go to the next page, and here are the definitions for mean and standard deviation. So the mean is just the lambda, the average per that interval, times how many intervals we're looking at. The standard deviation is the square root of the mean here. So basically the mean and the variance are the same for a Poisson process, because in the past we've talked about the square root of the variance is the standard deviation. So here is a simplified version of the Poisson distribution. So they've replaced lambda t with mu for the mean, and this is what you would want to use if we're going to use the function. So other than that, they just show you a few examples and how it's plugged in. We're going to be doing this with technology. Our most important focus is going to be understanding what distribution we're dealing with, and then being able to interpret the findings. So we're going to be using the StatCrunch definition, and we're going to go ahead and jump into my math lab.